All right, guys, so I just wanted to demonstrate a quick idea I had. Basically, the idea is to use the motors in your 3D printer to drive like a bellow for the open ventilator design. I've seen a few designs, like there's this guy right here on YouTube. He's driving this pump with a drill. And then there's also this email that I got from the guys who made my 3D printer. You can see right here that they want to drive this this bag, and it looks like you can drive it with the motor on the 3D printer. So the idea is really simple. You already have motors right here on your 3D printer. You already have a system talking to the computer. So you basically, if you could write the program to control the motors, you could move this bellow up and down. Now I want to make this really clear that I'm approaching this as a research project. I think it's kind of cool that people are working on this, but if you get something like this working, you don't really want to go hook it up to a person. So do this at your own risk. I'm considering this research, and also when you start telling this thing what to do, you could damage it. You could overheat these motors. So just do this at your own risk. So this is gonna be a little outline for my video. I'm gonna give a little abstract to how the 3D printer works, how the communication works between the computer and the 3D printer. Then we're gonna go over using a slicer to manually control it, and then we're gonna connect to the 3D printer in the terminal and use a bash script to kind of make it go up and down. Then go over some ideas of how you can program this with C++, and how maybe you can use an external sensors, like some pressure sensors in here, and interface it with G-code. So this is gonna be real quick and real bare bones, but it's just like a getting started kind of thing. So the first thing to go over is this abstract idea that like a 3D printer to the computer is a serial port, and you're gonna just send text in the form of G-code that tells this thing what to do. It's gonna listen to the G-code and figure out what it wants to do. So basically the computer sets up a serial port where you can send G-code, 3D printer handles the rest. So the next thing is how is using a slicer to manually control the 3D printer. Because typically, you run this program, like you might have Simplify 3D or something like that, is what I use. Let me open it back up. You're probably used to seeing something like this, and you hit prepare to print, and then, it generates code for you, and you just press print and it does its thing. But if you look behind the scenes, you can click this communication spot, and it can show you everything that's going on if you click verbose. So basically, like right now, it keeps polling. This is this code M105, which is basically asking the 3D printer, like, give me your status. So right now it's saying like temperature is 24.3 degrees Celsius. You obviously probably have done this at some point. You came over here and pressed this button, and you can see these things moving. Things like that. Let's go all the way to the end. And this is why you're doing this at your own risk, because you can keep sending code, it might damage your machine. I'm not responsible for that. This is your machine. Something you can do is you can turn on verbose and basically hit a command like this button, and then click over here. I'm gonna turn off verbose so it doesn't pop up anymore, and see what it did. So it sent this code right here. You can copy this code, hit this right here, and then press send, and then you notice it does something. So here's something that's kind of weird about G-code, and it's just kind of frustrating. There's two ways you can define a location. You can do absolute, or you can do relative. So I think out of the box it wants to do relative. I'm sorry, it wants to do absolute. So you send this, it's trying to put the X at the -10 spot, and you can see right here it says -10, but it's actually not a -10, it's at 0. So we can put this back actually at type in 0, and watch it, it's going to be wrong. It's going to move to what's not 0. And this is why you have like the home all button. So press like home X. Now it's back at 0, and if you send that exact same code, it doesn't do anything. And if you put X at 10, now it should move over a centimeter. And if you hit it again, it doesn't do anything. because you're in absolute mode. If you type in this code right here, the G91, which you notice every single time this thing sends something, it puts that in and then it puts it back in absolute mode. G91 puts it in relative. So we put G91 first. Okay, we're gonna send that, and then we're gonna send that same code we just ran. Let's move this to 10. Now every time we hit and send, it's gonna advance 10. Okay. So that's basically using the slicer to manually control your 3D printer, and we're using G-code. If you want to know more G-code, you can literally just go on the internet and type in G-code. You can get a list of codes. All right, so the next thing I want to go over is connecting the 3D printer in terminal. This is going to be mostly for Unix-based operating systems, so like Mac or Linux. I think on the new versions of Windows, this might actually work with Ubuntu, but you might have to look up, how to communicate over serial on Windows. I think it's probably going to be something like using what's the name of that program? Telnet. So in Unix, it's kind of weird that serial devices are treated as files. So basically, you're going to be given a file location, and you're going to write to that file to send something to the 3D printer. And whenever the 3D printer wants to send something back to the computer, it's like you're reading from the file. So you write to the file, and then you read from the file. So basically what we're doing is, instead of using the slicer to manually send G-code, we're going to go in terminal, and we're going to do this on our own. So I'm opening up terminal right here, and you can see I've already been playing with this. The first thing you want to do, let's just clear this, is you want to see what devices you have. And the way you do that is you type in ls/dev, and that shows you all the devices on your computer that you can write to like a file. These are like virtual files. I don't think they're even real files, period. If you notice right here, you got this cu.usb modem 621. That, for some reason, is the Maker Gear M2. I don't really know where that name came from, but that's what it is. And a way you can find this without just searching through it and trying everything, which is not a good idea, is literally open your slicer and look at the port right here. It says /dev/cu.usb modem 621. So it's showing you what it's talking to. So basically what you can do is you can send the code straight to this thing. So you type in echo and then what you want to send. So like G1, let's move the X thing 10. Let's do feed rate like 500. And then we're going to send that to /dev/ cu.usb 621, and it's going to say permission denied. What did I do wrong? Let me look at what I did earlier. I just typed it in wrong. All right, and now it's telling me resource is busy, and that's because I need to disconnect my 3D printer from this program. You're only allowed to use one at a time for some reason. So now we're going to send this again, and it did absolutely nothing. And why is that? Because over serial, you have to set the baud rate, which is the data communication clock. You don't really have to get into that, but basically if you look over here and see what the baud rate is, it's 115,200 bits per second. That's the clock speed of the serial communication. If the clock speed's wrong, the data just doesn't work. So it took me a while to figure this out, and I went through Stack Overflow, and on Mac you have to do something special. So I'm just going to show you the code real quick. I have it right here. So it's execute 3 caret, this little guy. So I'm gonna type it in, execute. I don't exactly know what this means. I found this on Stack Overflow. All right, so now we're connected to the 3D printer. And the next thing we need to do is set the baud rate. So you have to send this command. I have it on the GitHub where you can just copy and paste this. So that's going to set the baud rate. We're going to make sure it's right by sending this. Okay, so that's the speed it is. And that's right. That's the speed that you're supposed to have on Simplify 3D. So this should work. So now we should be able to send an actual command to this thing. So we're going to send echo G1. Let's go with X10. Let's put this to the feed rate to like 500. We're going to send this to our same little spot. Okay, and it moves. And if you can keep running this, and it doesn't do anything because we're in absolute mode. If you want to switch over to relative mode, send this guy. And then we can just keep running that. And that did not work. Because I typed the wrong command in. It's G91, not 91. All right. Okay, so I came here and wrote a little script that sets this up for me. This is a bash script. You can look up how to make bash scripts online. The big kicker with bash scripts is you have to type in chmod plus X and then the file name. For me, it's vent.sh. Before you can run it, you'll get like a permission denied if you don't do that. You can look this up on the internet and learn how to do it. So basically, this is my bash script. And if you download mine, you're gonna have to do this chmod thing. So this is my bash script. It opens the port. You know, it sets the baud rate. I have 2 lines doing the exact same thing, so I'll delete this one. We have here checking the speed just to make sure it's good, and then I have this loop that's supposed to be waiting for the file, the virtual file from the serial port to send back a new line, and it's supposed to be checking for an OK. Now I don't think it actually does this correctly. It's supposed to wait, but it doesn't. It just keeps sending an infinite loop. If you know, if somebody has a better idea how to set up this event loop, that would help me out a lot, because it's just basically sending out this G code over and over and over again and filling the buffer. And you know, that's obviously not going to work if you're trying to make a machine. But you know, just to demonstrate that you can do this, as I think it's fine. So what I'm going to do is I'm going to run this script. And then I'm gonna stick this guy in here, and it's gonna kind of compress it, just to kind of show you that, you know, you can use the 3D printer motor to drive these things. So I will run my little script real quick. So it's vent.sh, and it's waiting, as you can tell here, for an OK. So this is kind of a hack, but I'm just gonna send a basic. I'm gonna send a home. I want to home on the Z. All right, is this in focus? All right, so now you can see the bellow oscillating, and it's not pumping much. Found out that using the Z motor actually has a panic, so if it puts too much torque on it, it's just going to stop and fall to the ground. So you wouldn't want to use the Z motor. you probably would want to use the bed and control the y-axis. Also, the torque is something you need to consider. You need to look up the spec sheets on the torque of the motors and see, if your bellow is, over torquing it, and the amount of air pressure that you're using. This obviously starts becoming a mechanical engineering project versus a little programming demonstration. All right, so the next thing I want to talk about is how you can use C++ instead of a bash script. And basically, the easiest way to do this is, I don't have any examples because I haven't gotten to this yet. But if you guys remember like cin and then, read from a file, or like cout in C++, I think that's that way the arrows go. I have to look it up. It's a file. So you're sending to a file. There's one specific header that you have to import. And I don't think it's the part of this. I don't think it's standard IO. It's something else. But there's tutorials online. I have a link on the GitHub where you can find it. You're just writing to a file. Okay, so the next thing I want to talk about is connecting external sensors to the 3D printer. The circuit board that is in this 3D printer is called a Rambo, which stands for RepRap, which is the name of the open source 3D printer project Arduino Mega compatible motherboard. So this is the popular one. This is what I have in my device right here. You notice that it has some kind of extension ports. It has a motor extension, you have analog extension, you have SDI, SPI, you have I2C, you have a 32-bit extension. That's interesting. Some USB, things like that. So there's a few ideas that I came up with. Is you already have the temperature sensors already there. You already have the G-code for all that. You could probably just make a daughter board with a pressure sensor or a flow rate sensor, something like that, and give it an analog output that would kind of mimic what a thermistor puts out. That's kind of hacky, but that's one way you could do it. Another way is connect directly to this analog extension ports. You can look this up and see how it's wired in the schematic. You can find this online. You type in the Rambo schematic, they come up. So here's like your some extensions. That's a 32 one, and you can see how it's hooked up to the Arduino. Another one is I2C, which is probably the better one to use because you can buy off-the-shelf I2C pressure transducers and just interface that directly. And there's some experimental G-code, which we can look up. We'll see what, like, type in G-code I2C, where you can just talk to this using G-code and not have to mess with the firmware on the RepRap or anything. So basically, at the end of the day, what you would have is a C++ program that talks over serial using G-code, waits for it to get back, and then, controls the position of these motors. And also, if you want to have some kind of like PID controller, some kind of control system, you can also read the sensor values and use that to control like your flow rate or something like that. The whole point here that I wanted to demonstrate is that you can do this. You already have the hardware. The difficulty at this point becomes writing the software and just making a mechanical design to interface this. Is this the right direction to go to make a ventilator? Most probably no. Is this an easy thing for, like, if you have a team of a few guys who are working on this? Is this an easy way to test it without using, something like a drill? Yeah, I think it's totally doable. It also makes sense for like this to be a GitHub project where a few people can contribute to this. Like, if somebody would write the event loop, if somebody would write a driver for this, like a class to abstract away talking to the 3D printer, and you could just say, hey, send me the certain flow rate. And somebody else could write a class for handling a PID loop using some kind of pressure transducer, and somebody else would make like the thing handling the pressure transducer, and we could figure out we want to have this standard part. So that that's just one idea that I had, and I wanted to kind of share it and basically contribute something to the group. I think this is totally cool that people are trying to work on this. Obviously I don't think that you should hook this up to a person. And obviously we're not anywhere near that point, but I think it's just a better, more engineered direction rather than using a drill. So I wanted to present this. If you guys find this useful, let me know. If not, let me know too, because I'm kind of doing this right now. partially I could say I'm wasting my time, but at the same time, you know, we're not really allowed to do much right now. The whole world's kind of on lockdown, and at my age, you know, I kind of wanted to go to bars, but hey, I'm 3D printing stuff. So let me know what you guys think. Yeah, thanks for watching. I hope you got something out of this. Thank you.